Most data centers don't fail because of one big event. They fail because small conditions go unnoticed. A 2-degree rise near a rack, humidity creeping past the threshold, or a door left unlocked longer than it should be. Individually, none of these seem critical, but together they all lead to downtime. Today, I'm walking you through a real application story where we helped a large national data center move from manual checks to fully monitored 24/7 control, all without replacing their existing systems. We'll take a closer look at the problem they faced, the architecture we designed, the hardware we used, and the results they achieved, results that you can repeat in your own projects. So, let's start with the challenge. This facility had multiple server rooms spread across a large site. They needed continuous environmental visibility, temperature, humidity, and dew point, and they needed reliable access control at each room entrance. Up to this point, everything was done manually. Technicians performed regular patrols, reading data and logging it by hand. But by the time someone noticed a hot aisle running too warm, they were already reacting instead of preventing. And when access logs needed to be reviewed, the data was fragmented and inconsistent. So the goal became clear: centralize monitoring and control, reduce on-site patrols, and make the system smart enough to alert and act in real time. So here's how we made that happen. At each server room entrance, we deployed a PET7060 Ethernet I/O module. When one taps their card against the reader successfully, the PET7060 receives the query from the control center to open the gate. Conversely, when access is denied, the door remains closed and the data is sent back to the control center for activating alarm notifications. The system achieves access control effectively. Each module is PoE powered, meaning it runs both power and data through a single cable, simplifying installation, reducing wiring, and making the entire system more reliable. Inside each room, we installed DL100 EW remote temperature and humidity data loggers. These devices monitor temperature, humidity, and dew point and communicate through Modbus TCP or MQTT. That means they integrate seamlessly with modern SCADA and building management systems without requiring any additional hardware or coding. All of the field data from every door and every sensor is transmitted over Ethernet back to the control center. From there, the SCADA system aggregates everything in real time: door status, relay commands, temperature and humidity readings, and alarm events. The result is a single unified dashboard that shows every room, every threshold, and every condition at a glance. So now that we've covered the setup, let's see how this actually works in operation. When an engineer badges into a server room, the PET7060 detects the signal and instantly communicates with the control center. If the credential is valid, the control center sends the unlock command. If it's not, the door remains locked and the system automatically records the attempt and generates an alert. It's precise, automatic, and fully auditable. No guesswork and no paper logs. At the same time, the DL100 EW is monitoring environmental conditions near the racks. If temperature starts to rise or humidity moves outside a defined range, the system immediately generates an alarm. And because the modules are networked, you can even take it a step further, triggering automatic responses such as adjusting airflow, sending an email alert, or even logging data at a higher frequency for analysis. This is where the system really shines. Environmental data and access control working together continuously and automatically. It's not just reactive monitoring, it's proactive protection. Because as every data center operator knows, environmental control is only part of the story. To truly maintain reliability, you also need to understand what's happening electrically and how much power is being used and whether the quality of that power is stable. That's where the energy monitoring comes in. On the electrical side, we introduced PM3133 smart power meters to measure three-phase power at both the panel and circuit levels. These meters provide detailed insight into energy consumption, load balance, and power quality. All of that data is then sent to a PMC2241M power meter concentrator. This concentrator collects and stores the readings, runs if-then-else logic to trigger events, and forwards alerts to the control center. With dual Ethernet ports, it keeps the power network separate from the corporate network, a key design choice for both security and bandwidth management. By combining environmental, access, and electrical data in one place, the team gained full situational awareness. If a rack starts to overheat at the same time a circuit shows abnormal current draw, They can see both conditions instantly and respond before downtime occurs. Now, let's shift to reliability, because in this field, reliability is everything. Every device in the solution supports open protocols. That means the system isn't locked into a single vendor or proprietary platform. Communication is handled through Modbus TCP, ensuring fast integration and predictable performance across all devices. And if the SCADA server ever goes offline temporarily, the concentrator and meters keep logging data locally. Once the connection is restored, that data automatically syncs back to the control center, so there are no gaps in history. On the access side, relay control stays simple and deterministic. Doors open and close based on clear logic, independent of network latency or server load. Once the full system was in place, the results were immediate. Manual patrols dropped significantly because the system now records and trends all critical data automatically. Response times improved, since alerts were triggered as soon as values started to drift, not hours later when problems have already escalated. And access auditing became effortless. Every badge swipe, valid or invalid, is logged, timestamped, and synchronized with environmental data, providing complete traceability. From a design perspective, there were 3 key decisions that really made this deployment successful. First, using PoE devices throughout the system simplified installation, reduced power distribution costs, and made maintenance more predictable. Second, standardizing on Modbus TCP kept integration clean, open, and future-proof. And third, incorporating energy monitoring created a full feedback loop between environmental conditions and electrical behavior, giving the operators context, not just numbers. If you're planning a similar deployment, here's a proven framework you can follow. At each server room entry, use a PET7060 for your digital inputs and relay control. Tie in card readers, door sensors, and locks. Inside each room, position DL100 EW units at key points, near rack rows, C-rack units, or anywhere temperature and humidity are critical. Then route everything back to your control center over Ethernet and map the data using Modbus TCP in your SCADA system. For energy monitoring, install PM3133 meters at key distribution panels, PDUs, or high-load circuits and connect them to a PMC2241M concentrator. Use the concentrator's built-in logic to define alarms for abnormal voltage, current, or power factor. Forward those alerts to your existing alarm system or email notifications to your maintenance team. It's also important to keep your thresholds realistic. Too many alerts can cause alarm fatigue, which leads to missed events. Set pre-alarms for early warning and reserve critical alarms for serious limits. And wherever possible, tie alarms to automated actions like logging, notification, or relay triggers to keep the response immediate. And as your facility grows, scaling is easy. Each device has a unique address and uses open communication standards, so you can expand room by room without reworking the structure. And security follows the same principle, keeping it simple and intentional. Segment your networks, keep firmware up to date, and limit configuration access to authorized engineers. Because these are dedicated industrial devices, not general purpose computers, they operate with a smaller attack surface and greater stability. So let's wrap up by recapping the core hardware behind this solution. We use the PET7060 for Ethernet I/O and door relay control, the DL100 EW for temperature and humidity monitoring with Modbus TCP and MQTT, the PM3133 for accurate 3-phase power measurement, and lastly the PMC2241M for data concentration, logic execution, and dual network integration. Together, these components create a unified, reliable, and easily expandable system that gives you full visibility and control, all through open communication protocols and proven hardware. The key takeaway is simple. When your environmental data, access control, and energy monitoring all live within one coherent network, you move from reacting to preventing. That's how you protect uptime, reduce operating costs, and modernize your data center without starting over. If you're designing or upgrading a monitoring and control system, we can help. You'll find links to each product and a sample reference layout in the description below, along with the full application story. If you have any questions about Modbus mapping, PoE budgeting, or SCADA integration, leave a comment and we might cover it in an upcoming video. Thank you so much for watching, and make sure you subscribe for more walkthroughs on data center monitoring, power quality, and system integration. And if you're ready to start designing your own deployment, you can reach out to our team at sales@icp-usa.com, or you can head to our website at icp-usa.com. Thank you so much for watching.